Hi, today we are going to solve the 141st Leetcode problem that is called linked list cycle. What is inside the description? Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So what are the examples? Here you can see three examples. So in the first example, you can see that pos equals to 1. This means that the last node is linked to the node that has index 1. So here you can see cycle. In the second example, you can see that pos equals to 0, so means that the last node is linked to the node on the 0th place. And in the example 3, pos equals to -1. This means that this node is not connected to any node and is not connected to itself, and this means that there are no cycle. So how we will solve this problem? One possible variant, I think it's like naive solution, is just to go through the chain of the nodes and add every node to a set. And for example, let's start from this node. So here we adding this node to a set. Firstly, we check if this node exists in the set. If it doesn't exist, we are adding it to the set and getting the next node by, so in this node we just use variable next, field next, and by getting next we are going to the next node. For the next node we again checking if this node exists in the set. If it doesn't exist, we just add it to the set, and again and again. And here when we got here, we just even not here, but so we just get next. We appear here on the node 2 with value 2. In this case, we firstly check if the node exists in the set, and yes, it exists. So this means that here is the cycle. So we found a cycle, and we return true at this place. The same is with other examples. So let's start coding. So we will use set, like a set of list nodes. Let's name it set equals to new hash set. New hash set, and we have a cycle while. Of course, in this cycle we compare like this our current head with if it exists. If it is not null. Because if it is null, we should return false. And what next? So here we firstly need to compare if head if set, if our set contains the current node, so contains head, it means that we were on this node, we already were at this node. So this means that we got a cycle. So here we should return true. True that the cycle exists. What we should do next? Next we should add this current node to the set. Set has a method that is called add head, and then we should move our head, so our new head will equal to head point next. Yes, and if we went through all our cycle and we haven't got here at this place, so we should return false, because this means that we don't have our cycle. Let's check this. Contains. Okay, contains, of course. Misspelling. Misprint, I mean. Yes, we can see that all three cases accepted, so we can submit our solution. We can see that our solution is not the best one. And here we can use another one. So here is another method, another algorithm, when we have like two nodes. So let's have two nodes, like fast node and slow node. Fast node will the slow node. So let's we have list node that is called slow and equals to head, and the fast one is not fast equals to head. So in every cycle, in every iteration of our loop, what we will do? We will move slow by one, so just new slow will equal to like previous slow dot next, and fast will equal to head dot next dot next. In this case, slow node will move do step equals to 1, one step between nodes, and the faster node will move like will do this 2 steps, when the slow node does only 1. In this case, the faster node will go faster, and it can like appear when, for example, slow node will be here. The faster one will become on the same place, because it is faster. And this situation can appear that the faster and the slow node become on the same position. In this case, this means that we get a cycle. We have a cycle. And why this method can be better? For the previous variant has set. To create a set and to add new nodes for this set, we need to have additional memory and to perform additional operations. But if we have like two variables or two list nodes, we don't have to use additional data structure. we just need to move this node, so just to have again and again new objects for these nodes. In this case, it should be faster, and this should be more efficient. So so let's implement and check. What should we check inside the cycle? Inside the cycle, we need to first check if slow is not null. Then at the same time the fast node should not be null. And one more important thing, that the next node of fast should not be null too. So fast dot next. What else? So we should, to return true, we should compare slow and fast. So slow should equal to fast. And here we should use double equals, because it is about links, not only about the objects, but about links too. And what else? So before we compare, we need to move. So how we will move? So slow equals to slow.next, and fast equals to fast.next. It seems that's it, but let's check. Let's check if it works. Yes, we can see that it works, so we can submit. You see, the new algorithm is much more efficient, so it beats 100%. That's all. So the problem is solved. Thank you for watching.